Hello everyone, I'm Sefa Alperic from Bilkent University. In this video, I will talk about my term project for CMOS VLSI design course, which is a 64-bit correlator.
So the first part of the project consists on implementing a VHDL code for the 64-bit correlator. The correlator has 5 inputs and 3 outputs. The main functioning of the correlator is to get a serial input and compare it with already given datasets. To get the serial input, we are using the serial input pin. To get the decided datasets, we use the program in input. To control the correlator whether we want to program it or we want to function it, we use the program and run input. There is also a reset input for resetting the correlator and clock input for our general purposes. After the comparisons are done, 3 outputs are given accordingly. Sync represents whether there is a match or not with the given input and the datasets, or their inverted versions. Sync no represents which dataset is matched with the given input, and data pole represents whether the incoming input is in normal shape or inverted shape. After implementing my VHDL code, I take my VHD file and by using the genus synthesis, I created a gate level Verilog file, as you can see here. After generating this file, I tested it for 4 different supply voltages and different clock rates. As you can see, minimum energy day product occurred when there is a 1.8 volt supply voltage and 15 nanoseconds clock rate. After that, I started designing my layout. So first, I placed my cells on the floor pan. After that, I created the power rigs and connected the VDD and ground to the core from the pads. After this process, I created the clock route and then optimized it. After the optimization, I verified my design, and after the verification, I generated my layout. After that, I tested my chip once again with 4 different supply voltages and different clock periods. As you can see in this table, the lowest energy day product for the worst case delay occurred when there is a 1.8 volts supply voltage and 40 nanoseconds clock period. After that, in the last part, I created test patterns for my chip. I put 2 input test patterns and 1 output. The input patterns are SE and SI, and the output pattern is SO. After placing them and testing my chip once again, I found the power, setup time, and area of my chip for the supply voltage I already chosen. Thank you for watching.